to firm up our design. So we, as an expediency, went to this. Rand has been developing some very nice video stuff. They were kind enough to show us how these controllers and all would work with video. So we went ahead with this very simple brute force way of having the video signal generated by looking at a small CRT. Well, it turns out that that little CRT, its incremental cost, the video camera, the controller, and a monitor total about $5,500, which is cheaper than most fairly good resolution random deflection display monitors would be. So we come out well on the price of the hardware. Turns out that also that the cathode of the camera tube in just black and white usage like this, you can back off the scanning current of it so that it's a sticky cathode, so that actually it doesn't erase the image on it by each sweep. It may take 3 or 4 scans. And so with something like a 15 cycle a second refresh rate on those CRTs, the camera, the one that's generating this as well as the one we looked at it with a few minutes ago, have short-term storage in there. It's quite different from long persistence, but gives us the flicker-free display here for quite a flickery display there. This lets us use that display generation hardware for 3 to 4 times as many display stations as otherwise. You'll notice if we get just the text alone that there's a small effect by that bug smearing, but it's not that bad. And that comes from the memory in the Vidicon tube. Okay, so much for that. I'd like now to have us bring in Jeff Rulifson from Menlo Park, and we'll switch to his console. He's sitting at one just like this, been working independently. Hi, Jeff.
Oh.
We're not hearing you very well.
Oh, you're not hearing me? How about now?
That's fine.
Okay.
All right. I'm sorry you can't see everybody here, but I can't very well either because of the lights. So we're about even.
Okay.
I'd like you to talk to them about the way the special languages have helped in making flexible design and study available for us of the user features, the functions and the repertoire of the commands, as well as the control dialogue for them. And then also, it'd be an interesting example here because programmers, you programmers are the ones who most intensely found use for working online as we're building up. Show them how you structured your system guide. Okay?
Okay. I think we can do that. We can get sort of a good feeling for the way the whole system is put together by looking through the system guide. The file is one that system programmers sort of put together, help them get around. NLS right now is getting to be a fairly large program. It's not huge by a lot of standards, but it's getting pretty big. This picture in our system guide file is a picture of the overlay structure. Our overlays are page sizes, so they're not too big in the 940, but each label in this picture names a code file, and each one is 3 to 20 pages long. I mean 20 text pages if you printed them out. Just to sort of show how you can use a file like this to move around in the code, and also how the code is put together. As I said, each label in the picture is the name of an overlay, which is also the name of that file, but it also happens to be the name of a statement in this file. By selecting one of these pictures and moving there, I was going to do something for you to let you see better. What did I do?
Yeah,
we go back to the origin and start over again.
Brings back all the parameters.
There. Now let me move out. From the picture, I can move to a little section in this file, which is an area that system programmers leave around notes for each other. There's nothing much interesting here. A little bit about the documentation and the patch space that's left. Right from this spot, I can actually move out to the file. Suppose that I were going out in that control meta language Doug was talking about and just try to see, for example, the routines used in the delete word or move word. Let's go look at move word construct. I just select this link, and here is the file. This file is written in one of these many special languages that we've designed. So I just move down through it, find the move commands. Move, let's look here for move word.
You want to point out how you know it's move word?
Yeah, well, I was just going to look at that, Doug. As I was stepping down through that, I was sort of not only moving through the file, but the structure of the code is rigged in such a way that it's a description of a finite state machine. And so I was following the characters a person would type to execute that command. Down here underneath it, I see that the routine is QMW over in the overlay text edit. So let's go back to that other file. Move back to our picture again and find where overlay text edit is. It's right down here, so we'll go and sort of move down through that one. The text edit overlay illustrates a lot of the different kinds of things that we've done. This file has two major kinds of code in it. First one is many of these different special languages that we've built up. See, I'm trying to find QMW. That's right. It's down here someplace. There we go. Let's see. Oh yeah, it's the two kinds of code. This is still the kind from the other file, but the QMW routine, the first subroutine, the second subroutine that it calls, which is sort of interesting, is move word, or word delimiter, I'm sorry. This routine is written in our content analysis language, and it takes a text string and finds the definition of a word. It looks out for punctuation, and it finds any special blanks around it, and finds pointers that describe that word. Another interesting one is the next subroutine here. If we look at it, it's in another special language that we've built up. It takes the pointers left over from the delimiter routine and the text in the file and reconstructs the statement after the edit's been done. Let's see. Where was I in this file? The other portion of the file is written in the language that we call MOL. It stands for Machine-Oriented Language. The MOL is in a sense, it's a high-level language in that it has phrase structure and good control constructs like if statements and while statements, but it's also very, very close to machine language, 940 machine language. People talk about the actual registers of the machine, and you talk about doing indirect addressing. This language has helped us write the kind of fast, tight code that we want, that we have to have to operate in the time-sharing system. And at the same time, it's given us a lot of flexibility. It's also, the phrase structure of the MOL is designed to sort of mesh with the block structure of NLS. So here I've got a while statement. To see what's in that while statement, I can move down and see its three statements, which is an if statement. The if statement is a single if statement, which has an if and an else part. And that whole block opens up to all of that. So by using the MOL like this, I'm able to move around very quickly in my MOL files. Also able to sort of zoom in and out of things. One of the, besides the sort of program organizational benefits that we get from designing all the special purpose languages, we've been able to design the syntax of these languages so that they fit with our linking structure and the conventions that we've set up and the aids we've built to help us in NLS itself to move around between them. One of the ways we've managed to implement all of these languages is by designing a compiler which we call tree meta. All of our compilers are written in tree meta. I'd like to add that we're very thankful to some people at Systems Development Corporation for helping us get started on a lot of the notions in tree meta. Erwin Book and Val Shorey were just invaluable in helping us get started. By having all of our compilers written in a higher level language themselves, we've been able to change them all the time. So we're not only able to quickly modify the syntax of the control language for NLS itself, or the meanings of the commands by working in our high level language, but we're also able to go in and just change the compilers as quickly as we have to accommodate all sorts of new hardware features and experimenting that we do like that. So in a system guide file, there were 3 sections. The first one served this program structure, and the picture and the fast links we looked at were sort of aids that the system programmers have built up to just move back and forth and leave notes. Second section here is on retrieval. I think I'll let that go for a while right now. The third section, more notes that programmers leave around about bugs, things that are wrong with our system right now. I got my blank line off. How did I? Well, anyway, one of the interesting things that NLS does, just an advantage of being online, is it keeps track of who you are and what you're doing all the time. So on these statements, on every statement that you write, it keeps track of who you are and when you did it. So not only can people leave notes around for each other, but sort of automate it into how there's an automated aid here that tells us who did it and when they did it. I can set up search patterns. I think these will probably be talked about later. So that sort of summarizes what the thing looks like and how it's put together. Is there anything that I haven't talked about, Doug, that we were supposed to bring up?
I think you've
looking at my notes right here.
You're doing very well, Jeff.
Thanks.
You ought to see yourself with a 15-foot face.
I'd like to.
Great.
I guess I'll just turn it back to you then. I might add that people want to come up to our room sometime. We're more than anxious to talk to people about languages and meta-compilers and all of the games that system programmers like to play. So I think I'll sort of turn it back with that.
Well, Jeff, how about going back to that place in the control meta language where you start down the dialogue protocol a person would use?
Okay. Right over here in main control.
Yeah. And off to another file where we're looking at real code now. And there's a branch of it down there.
Yeah. These top branches are all subroutines that are pretty meaningless. And this WC means what case, and it's what's right. The person going to ask for.
So open that one level down now. Right. Now, all those things in parentheses that in NLS are the names of those statements are actually in the programming language that works here, the way it's identified, that's the character a user hits. If he hits a D, for instance.
A D here for delete?
Right there. All right. If he hits a D, that line tells you what the response is supposed to be. That the computer's supposed to display certain material on the top of the screen. And then it's supposed to wait until the user does the next thing. Why don't you trim it to one line?
Yeah, I was going to do that. Why doesn't my branch only work? Oh, that's all that branch. Okay.
Hit EBT.
Well,
it's easy.
Okay.
I don't want to insult you by saying that it's easy to get a new view. Down there to say, all right, then if he's hit a D and it sets up what it says there, you can up one level below it, and that's the next block down in this special language, and you see, well, if after the D he hits something else like a W, it goes on from there to say what it is the computer's supposed to do in response. So this language here in its hierarchical structure, resembling the branching tree of choices user makes, specifying at every point what the computer does in feedback and the optional choices, and down in the end then specifying the actual function, like deleting a word. What's a word? And what do you mean by delete? And for what's a word, that's specified off in the subroutine he showed you in a special language to find in there what a word is. And it doesn't take a lot of programming skill to learn how to read these languages because they're at the concept